Hey guys, today we're going to do 4-1 quadratic functions and transformations. You will be able to identify and graph quadratic functions. And our essential understanding is the graph of any quadratic function is a transformation of the graph of the parent quadratic function, y is equal to x squared. So, our parent function that we are working with right now is the quadratic function, which is f of x is equal to x squared. And it is a graph of a parabola, which is our U-shaped graph, and our axis of symmetry goes through our vertex, which are all vocabulary words that are familiar to us from absolute value. But in our parent function, the axis of symmetry is x is equal to 0, and our vertex is 0, 0. So vertex form, we have f of x is equal to a times b minus h squared plus k. A cannot equal 0, and this is what we will be using if we are referring to vertex form. This is called vertex form because we can easily locate our vertex of the parabola. It is opposite of the inside, which we have been saying the entire time. So opposite of h, the outside. K would be our vertex. And our axis of symmetry is the line that divides the parabola into two mirror images. Our axis of symmetry is x is equal to the opposite of h because we have to take the opposite of the inside. Graphing quadratic steps. 1. Plot our vertex. Remember, just like absolute value, opposite of the inside, outside. We are also going to draw our axis of symmetry while we plot the vertex. Then we are going to pick two x values on one side of our axis of symmetry to find the y values. Once we have those points, we can then reflect the points to complete our parabola. So 1, g of x is equal to x squared minus 5. Step 1, vertex. We want to remember our vertex form of a quadratic, a times x minus h squared plus k. Since we have nothing on the inside, our x coordinate is 0. On the outside, we have negative 5. So that means we are going down 5. 0, 5 is my vertex, and I can draw my axis of symmetry. I'm going to pick one side of my axis of symmetry. So I'm going to pick the right side, and I'm going to make a table of values. I have x, and I have y. In order to pick the values, I pick the next x value. So next to my axis of symmetry, the value next to it to the right is 1 and 2. That means I plug in 1 and 2 into my original equation. So 1 squared minus 5 is equal to 1 minus 5, which is negative 4. Or 2 squared minus 5, which is equal to negative 1. So I now have the coordinate points 1, negative 4, and 2, negative 1. I'm going to plot those. 1, negative 4, 2, negative 1, and then reflect over the axis of symmetry. And I connect with a U. Arrows are on both ends of my parabola because they are going up and out forever. H of x is equal to x minus 4 squared. Start with our vertex. Opposite of the inside is 4. Outside is 0. Go to the right 4. Plot a point and draw my axis of symmetry. You can pick the left side or the right side. I'm just going to stick with the right side. So the next x value would be 5. And the next x value after that would be 6. We need to stay on the same side. I then plug in 5 minus 4 squared, which is 1 squared, which is 1. 6 minus 4 squared, which is 2 squared, which is 4. I plot those points, 5, 1, and 6, 4. I reflect them over my axis of symmetry and connect with a parabola. When a was negative while we were transforming functions, that means we reflected over our x-axis. That is the same thing when we have a parabola. So if a is greater than 0, we open upward. And our vertex is a minimum value. If you can see, that is the lowest value on your graph. If a is less than 0 or if a is negative, we open downward, making our vertex a maximum value because that is the highest value on our graph. So for y is equal to 3 times x minus 4 squared minus 2, we need to find the vertex, axis of symmetry, the maximum or minimum value, and the domain and the range. So first, vertex. Vertex is opposite of the outside, opposite of the inside, the outside. Opposite of the inside is 4. Outside is negative 2. Therefore, we have our vertex. From our vertex, we can sketch this. 4, negative 2. I know my axis of symmetry then goes through my x coordinate, so x is equal to 4 is my axis of symmetry. Maximum or minimum value is going to be told to me whether or not a is negative. So if a is positive, that means I open upward. If a is negative, I would open downward. Since a here is 3, that means I open upward, making my vertex a minimum. Now we have to think about the domain and the range. So if I have my vertex and I'm opening upward, domain is my x values. Do we have any restrictions on where my x values will be? I have to think about, do I have any restrictions on what x values I can plug in? Since I do not, my domain would be all real numbers. My y values do have restrictions because my graph does not start until y is equal to negative 2. And then at negative 2, we are going up and out forever. So my range starts at negative 2. It's including negative 2 since negative 2 is part of the graph, so I put a square bracket. And going on forever means we are going to infinity. What is the graph of negative 2x minus 1 squared plus 3? Vertex, opposite of the inside, outside. 1, 3. Graph my axis of symmetry. Pick one side. I'm going to still go to the right. So the value next to 1 would be 2. Therefore, negative 2 times 2 minus 1 squared plus 3. 2 minus 1 is 1. 1 squared is 1. 1 times negative 2 is negative 2 plus 3, which is equal to 1. Therefore, I have my first point at 2, 1. And then I can pick a new point. I'm going to pick the next point over, which is 3. Negative 2 times 3 minus 1 squared plus 3. 3 minus 1 is 2. 2 squared is 4. 4 times negative 2 is negative 8 plus 3, which is equal to negative 5. Therefore, my next point is 3, negative 5. And I reflect 1, 2, 1, 2, 1, 1, and connect with a U. The U is called the parabola. And this makes sense that my parabola is opening downward because my A value was negative. You guys try this one on your own.